There is something wonderfully ordinary about sunrise. It happens so faithfully that most of us rarely stop to think about it. Morning arrives. The darkness slowly retreats. Soft light spills across rooftops, forests, oceans, and mountains. Birds begin to sing. The air gradually warms. Another day quietly begins. For most of human history, this simple rhythm has felt permanent. The sun has always returned. Generation after generation has awakened beneath the same familiar star. Children have watched their first sunrise. Farmers have begun their work with its first rays. Travelers have used it to find their way. Entire civilizations have organized their lives around its dependable journey across the sky. Long before clocks measured hours, the sun was already keeping time. Its rising marked the beginning of labor. Its highest point divided the day. Its setting signaled rest. Without speaking a single word, our nearest star became Earth's oldest clock. Every culture learned to follow its rhythm. The ancient Egyptians watched the sun travel across the heavens as a symbol of rebirth. The Greeks imagined Helios guiding his radiant chariot from one horizon to the other. The Inca regarded the sun as the great protector of their civilization. Across Asia, Europe, Africa, Oceania, and the Americas, countless traditions celebrated the return of daylight after every night. Although their beliefs differed, nearly all shared one quiet understanding. Life depended upon the sun. It warmed the land. It guided the seasons. It determined when rivers flooded, when crops could be planted, when animals migrated, when forests bloomed. Without realizing it, every civilization lived according to the heartbeat of a single star. Even today, despite satellites, electricity, and artificial light, very little has truly changed. Every forest still grows because sunlight reaches its leaves. Every ocean current is influenced by energy arriving from the sun. Every breath we take is connected to plants that transform sunlight into food through photosynthesis. The meal on your table, the oxygen in your lungs, the clouds drifting overhead, all of them exist because of energy that began its journey nearly 150 million kilometers away. It is remarkable to think that nearly every form of life on Earth shares the same ultimate source of energy. The sun asks for nothing in return. It simply shines, day after day, year after year, for so long that its reliability has become invisible. Perhaps that is the greatest compliment we can unknowingly give something. To stop noticing it because it has never failed us. We rarely wake up wondering whether the sun will rise tomorrow. We simply assume it will. The thought hardly crosses our minds. Our confidence is understandable. Throughout recorded history, the sun has never broken its promise. Empires have risen beneath its light. Empires have disappeared beneath that very same light. Languages have evolved. Religions have changed. Borders have shifted countless times. The continents themselves continue drifting almost imperceptibly across Earth's surface. Yet every morning, the sun has remained, watching silently, unchanging. At least from our perspective, there is comfort in such stability. Human life is filled with uncertainty. Storms arrive unexpectedly. Seasons sometimes disappoint farmers. Families change. Cities transform. Entire generations pass away. But above all those changes, one brilliant star has continued shining with astonishing consistency. It is easy to mistake that consistency for permanence. Yet astronomy gently reminds us that permanence is often an illusion created by timescales much larger than human lives. The mountains appear eternal, yet they slowly erode. The oceans seem timeless, yet they continuously reshape coastlines. The stars themselves appear fixed, yet they are constantly moving through the galaxy. Even the sun, our faithful companion, is changing, only very, very slowly. So slowly that no human lifetime could ever notice it. Its light has remained almost perfectly stable throughout the entire existence of civilization. Not because stars never change, but because the lives of stars unfold across billions of years. Compared to them, human history occupies less than the blink of an eye. Imagine compressing the entire lifetime of the sun into a single calendar year. Its birth would occur on January 1st. The dinosaurs would not appear until late December. Human civilization would occupy only the final seconds before midnight on New Year's Eve. Everything we call history, every city ever built, every book ever written, every scientific discovery, every love story, every song, every dream would unfold within those final, fleeting moments. From the sun's perspective, humanity has only just arrived. And yet, during that brief instant, we have learned something extraordinary. We have begun to understand the very star that made us possible. We know it is not simply a glowing disk crossing the sky. It is an immense sphere of superheated plasma, a nuclear furnace producing unimaginable amounts of energy every second. A star among hundreds of billions inside the Milky Way. Ordinary by cosmic standards, extraordinary to us. Because without it, none of us would be here. That realization quietly changes the way we see every sunrise. What once seemed ordinary begins to feel astonishing. The light reaching your eyes each morning has traveled across space for about 8 minutes. When you watch dawn break across the horizon, you are witnessing sunlight that left the sun while you were still asleep. 8 minutes earlier, those photons escaped the surface of our star. They crossed the emptiness between worlds at nearly 300,000 kilometers every second. Only now do they arrive. Only now do they illuminate your morning. Every sunrise is an ancient message, a gift that has already been traveling before the day itself begins. Perhaps that is why sunlight often feels so peaceful. It has crossed millions of kilometers without hurry, patiently, faithfully, for billions of years. Now imagine something almost impossible. Imagine waking tomorrow morning. The sky looks perfectly ordinary. Birds sing. The breeze feels familiar. The sunlight appears warm against your skin. Nothing seems unusual. Yet, deep inside the sun, far beyond anything human eyes could ever observe, something has changed. Not a solar flare, not a sunspot, not one of the natural cycles astronomers have studied for centuries. Something entirely unexpected. Something no scientific model predicted. At first, no one on Earth notices, because the first signs of extraordinary events are often invisible, long before the world begins to worry, before headlines appear, before governments meet, before scientists make announcements. A handful of observatories quietly detect numbers that should never have changed. And with those impossible measurements, humanity begins asking a question it has never seriously needed to ask before. What if the star that has faithfully illuminated every chapter of our history had just begun telling its final story? Before we imagine our sun beginning to die, it helps to understand why scientists are so confident that it will not. That confidence does not come from hope. It comes from physics. For thousands of years, people admired the sun without knowing what it truly was. It appeared as a perfect circle of light crossing the sky. It brought warmth during the day and disappeared every evening beyond the horizon. Ancient civilizations measured time by its movement. They built monuments aligned with its rising. They celebrated its return after the longest nights of winter. The sun was familiar, essential, mysterious. No one knew what allowed it to shine so steadily. Some imagined it as a divine fire. Others believed it was an eternal flame that could never fade. The truth turned out to be even more extraordinary. The sun is not burning the way a campfire burns. There are no flames consuming wood or oxygen. In fact, if you could somehow place ordinary fire inside the sun, it would make almost no difference. The source of the sun's energy lies much deeper. At its very center, hidden beneath hundreds of thousands of kilometers of intensely hot plasma. Our story begins long before Earth existed. Around 4.6 billion years ago, a vast cloud of gas and dust drifted through a quiet region of the Milky Way. This enormous cloud, known as a molecular cloud, contained mostly hydrogen, along with smaller amounts of helium and traces of heavier elements forged by even older stars. For millions of years, the cloud remained calm. Then, something disturbed its balance. Perhaps the shock wave from a nearby supernova. Perhaps the gravitational pull of neighboring clouds. Whatever the cause, one region became slightly denser than the rest. Gravity quietly took over. The denser region attracted more material. As more gas gathered together, gravity became even stronger. The cloud slowly collapsed inward. This process continued for hundreds of thousands of years. The growing sphere became hotter and denser. Matter fell inward. Pressure increased. Temperature climbed higher and higher. Eventually, at the center of the collapsing cloud, conditions became almost unimaginable. The temperature reached roughly 15 million degrees Celsius. The pressure became so enormous that something remarkable happened. Hydrogen nuclei began colliding with enough force to overcome their natural electrical repulsion. Instead of bouncing apart, they fused together. Nuclear fusion had begun. This was the moment our sun was truly born. Fusion is one of nature's most elegant processes. 4 tiny hydrogen nuclei gradually combine through a sequence of reactions to form one helium nucleus. The helium weighs ever so slightly less than the hydrogen that created it. The missing mass has not disappeared. It has become energy, exactly as Albert Einstein described with one of the most famous equations in science. E equals mc squared. A tiny amount of mass transformed into an enormous amount of energy. Every second, the sun converts approximately 600 million tons of hydrogen into helium. Of that staggering amount, roughly 4 million tons of mass become pure energy. Every single second, without pause, without interruption. The numbers are almost impossible to picture. Yet despite this unimaginable power, the sun has enough hydrogen to continue this process for billions of years. Its fuel supply is truly immense. But fusion alone is not what makes the sun remarkable. Its greatest achievement is balance. Gravity constantly tries to crush the sun inward. Every particle inside the star is being pulled toward the center. If gravity acted alone, the sun would collapse. Fusion pushes in the opposite direction. The enormous energy released inside the core creates pressure. That pressure pushes outward. For billions of years, these two forces have remained almost perfectly matched. Gravity pulls inward. Pressure pushes outward. Neither side wins. Astronomers call this state hydrostatic equilibrium. It is one of the reasons the sun has remained so stable throughout nearly its entire life. Imagine balancing a pencil perfectly on the tip of your finger. It seems almost impossible. The slightest movement causes it to fall. The sun's balance is very different. Instead of being fragile, it is remarkably self-correcting. If the core were somehow compressed slightly, its temperature would increase. Fusion would speed up. More energy would be produced. Greater pressure would push the core outward again. If the core expanded too much, the opposite would happen. Temperature would decrease. Fusion would slow. Gravity would gently pull everything back inward. The star naturally corrects small disturbances. It is an elegant cosmic feedback system. This is why astronomers often describe the sun as a remarkably stable star. Not because nothing changes, but because change happens with extraordinary patience. The sun has not shone with exactly the same brightness throughout its history. In fact, it has gradually become brighter over billions of years. When Earth first formed, the sun produced only about 70% of the energy it emits today. Slowly, very slowly, its brightness has increased. The change has been so gradual that life has continuously adapted. No human being could ever notice such evolution during a lifetime. Even entire civilizations are too brief to measure it directly. Our lives unfold far too quickly compared with the rhythms of stars. Like every star, however, the sun cannot shine forever. Its hydrogen fuel is finite. One day, billions of years from now, the hydrogen inside its core will become scarce. Fusion there will begin to slow. Gravity will once again gain the upper hand. The core will contract, but the story will not end. The increasing pressure inside the contracting core will heat the layers surrounding it. Hydrogen fusion will continue in a shell outside the core. As more energy pours outward, something extraordinary will happen. The sun will begin expanding. Its outer layers will slowly grow larger and larger. It will enter the phase astronomers call a red giant. Its surface will become cooler than it is today, giving it a reddish appearance. Yet, despite that cooler surface, the star as a whole will become vastly more luminous because of its enormous size. Mercury will almost certainly disappear inside the expanding star. Venus will likely share the same fate. Earth's future is less certain. Some models suggest our planet may also be engulfed. Others indicate that changes in the Sun's mass could allow Earth's orbit to drift slightly outward. Even if Earth survives physically, its oceans will already have vanished long before then. Its atmosphere will have changed beyond recognition. Our world will no longer resemble the blue planet we know today. Fortunately, none of this will happen tomorrow, nor next year, nor next century, nor even within the lifetime of our species. If humanity survives for millions of years, according to everything modern astrophysics tells us, the Sun still has roughly 5 billion years before reaching the red giant stage. 5 billion years. That number is difficult to appreciate. The oldest civilizations appeared only a few thousand years ago. The dinosaurs disappeared 66 million years ago. 5 billion years stretches so far beyond human imagination that it almost loses meaning. Compared with that time scale, every concern we carry today belongs to a tiny instant. This remarkable stability is one of the greatest gifts our planet has ever received. Life requires consistency. Complex ecosystems need time. Evolution needs patience. Civilizations need predictable seasons. Without a stable star, none of those things could exist for long. Earth has enjoyed billions of years beneath one of the most dependable stars in the galaxy. That quiet reliability allowed forests to grow, oceans to flourish, dinosaurs to roam, mammals to evolve, and, eventually, a curious species capable of asking questions about the universe. Everything we know owes its existence to the extraordinary patience of our Sun, which is precisely why our thought experiment feels so unsettling. Because if a star this stable, a star whose future seems understood with such confidence, suddenly began behaving in ways no theory could explain, humanity would immediately realize something extraordinary was unfolding, not in the distant future, not billions of years from now, but here, now. And the first people to notice would not be standing outside watching the sunrise. They would be quietly working inside observatories, staring at numbers that suddenly refuse to obey the laws of physics. The first sign would not appear in the sky. It would appear on a screen. Somewhere inside a quiet observatory, long before the rest of the world had finished breakfast, an automated monitoring system would register a measurement that seemed impossible. At first, no one would panic. Observatories collect enormous amounts of data every day. Tiny anomalies happen all the time. A detector becomes slightly warmer than expected. A telescope loses its alignment by a fraction of a degree. A satellite experiences a brief communication delay. Most unusual measurements have perfectly ordinary explanations. The first instinct of every scientist is not excitement. It is skepticism. Perhaps an instrument needs calibration. Perhaps a sensor has failed. Perhaps software introduced an unexpected error. The simplest explanation is usually the correct one. So the researchers would begin checking everything. They would compare measurements taken by different instruments. They would verify timestamps, examine environmental conditions, Restart computers. Repeat observations. Nothing unusual. Everything appears to be functioning exactly as it should. And yet, the numbers remain the same. The sun is behaving differently. Not dramatically. Not in a way that anyone standing outside could possibly notice. Its light still reaches Earth. Its familiar warmth still touches the ground. The blue sky remains unchanged. Children continue walking to school. Airplanes cross the morning sky. Cities begin another ordinary day. To everyone else, the world feels perfectly normal. Only a handful of specialists know that something has quietly changed. Within hours, observatories across the world begin comparing data. Solar observatories in Europe, North America, South America, Asia, Australia, orbiting spacecraft positioned far beyond Earth's atmosphere. Independent instruments, independent teams, independent analyses. One by one, they all arrive at the same uncomfortable conclusion. The anomaly is real. No known process inside the sun predicts what they are seeing. Inside conference rooms and research centers, conversations become increasingly serious. Nobody wants to draw conclusions too quickly. Extraordinary claims require extraordinary evidence. That principle has guided science for generations. Researchers know that mistakes become headlines far more easily than corrections. So they proceed carefully, patiently. Every possibility is tested. Every explanation is challenged. Could another astronomical object be interfering with the measurements? Could an unexpected cloud of interplanetary dust be affecting observations? Could several independent instruments somehow share the same hidden flaw one by one? Every ordinary explanation disappears. What remains is deeply unsettling. The sun itself has changed, not according to any model, not according to any prediction, simply changed. The scientific community now faces an unfamiliar situation. The most carefully studied object in human history has done something nobody expected. For centuries, astronomers have observed the sun with increasing precision. Its magnetic cycles, its sunspots, solar flares, coronal mass ejections, oscillations beneath its visible surface, its chemical composition, its rotation, its energy output. Few objects in the universe have been examined so closely, precisely because every form of life on Earth depends upon it. And yet, this new observation fits none of those categories. It is something entirely different. The first confidential messages begin moving between research institutions. Not public announcements, not press releases, quiet emails, encrypted communications, emergency video conferences. Small groups of experts gather behind closed doors. Physicists specializing in stellar evolution, solar astronomers, experts in nuclear fusion, computational modelers, satellite engineers. Everyone brings their own perspective. Everyone hopes someone else has an explanation. Hours pass. No explanation comes. By late afternoon, the number of people aware of the anomaly has grown significantly. Government scientific agencies receive preliminary reports. Space agencies begin internal discussions. International observatories coordinate additional observations. The world's largest solar telescopes are directed toward our star with renewed urgency. Every available instrument begins collecting more data than ever before. It is a strange feeling. Humanity has spent thousands of years watching the sun. Now, for the first time, it feels as though the sun is asking us a question instead. As evening approaches in different parts of the world, rumors begin spreading through scientific communities. Researchers notice unusual activity among colleagues, unexpected meetings, canceled conferences, urgent requests for data. Most people still know nothing, but scientists have learned to recognize the quiet signs that something important is happening. Speculation begins. Could this involve an unusually powerful solar storm? A previously unknown magnetic phenomenon? A calibration error affecting multiple observatories? No one knows. Social media fills with guesses. Most are incorrect. The truth remains inside laboratories and observatories, protected until enough evidence exists to justify a public statement. The responsibility weighs heavily on everyone involved. How do you announce uncertainty about the one object every human being depends upon? Too early, and you risk causing unnecessary fear. Too late, and people accuse you of hiding the truth. Science has always balanced caution with transparency. Never has that balance felt more delicate. Finally, after nearly an entire day of verification, the evidence becomes overwhelming. Every major solar observatory has independently confirmed the same result. The measurements agree. The instruments agree. The models do not. A carefully worded statement is prepared. Every sentence is examined repeatedly. Every claim is supported by data. Every unnecessary speculation is removed. The announcement does not mention catastrophe. It does not predict disaster. It simply says that astronomers have detected unexpected changes inside the sun that current theories cannot yet explain. Additional observations are underway. More information will follow as soon as possible. The statement is released simultaneously around the world. Within minutes, news organizations interrupt regular programming. Headlines appear across countless languages. Television anchors struggle to summarize highly technical information. Experts are invited into studios. Some urge calm. Others admit they have never seen anything comparable. Across the internet, millions of people begin searching the same question. Is the sun dying? Scientists answer carefully. No. At least, not according to anything currently understood. The sun is still shining. Its light remains stable enough that no one could notice a difference without sophisticated instruments. There is no immediate danger, no reason to panic, but there is also no explanation. And sometimes, the absence of an explanation is more unsettling than bad news itself. As night falls across parts of Earth, people step outside for reasons they cannot fully explain. The stars look exactly as they always have. The moon continues its quiet journey across the sky. Everything appears beautifully ordinary, yet something has changed. For the first time in history, billions of people look toward tomorrow's sunrise, not with certainty, but with curiosity. The sun has risen every morning for all of human history. No one truly believes tomorrow will be different. And yet, for the first time, many silently wonder, what if it is? Meanwhile, 8 minutes away, at the speed of light, the next sunrise has already left the surface of the sun. Whatever happens there now, Earth will not know for another 8 minutes. Humanity has suddenly become aware of something that was always true. We have never experienced the sun in real time. We have always lived 8 minutes behind our star. And tomorrow morning, those 8 minutes may feel longer than ever before. The next morning arrives, almost exactly as every morning before it. The sun rises above the horizon. Its familiar golden light spreads across fields, cities, deserts, and oceans. For most people, nothing appears unusual. The warmth on their skin feels the same. The sky remains blue. Birds continue their songs. The world wakes as it always has. If someone had never heard yesterday's announcement, they would likely notice nothing at all. And that is perhaps the strangest part. The greatest changes in nature often begin so quietly that they hide inside ordinary moments. The scientists who spent the night studying fresh observations are the first to notice that the anomaly has continued. The unexpected measurements were not a temporary fluctuation. They were the beginning of a trend, minute by minute, hour by hour. The amount of energy leaving the sun is changing. Not dramatically, not enough to darken the sky or plunge Earth into immediate chaos. The difference is incredibly small, measured only by instruments capable of extraordinary precision. But unlike the sun's normal fluctuations, this change is persistent. It continues. Every new observation confirms what researchers feared. Something deep inside our star is no longer behaving as expected. The sunlight reaching Earth today still began its journey 8 minutes ago. Its brightness appears almost identical to yesterday's, yet sensitive detectors distributed across the planet register tiny variations. They are so small that no human eye could ever perceive them. Even the most careful observer, standing beneath the open sky, would notice nothing unusual. Nature often whispers before it speaks. Days pass. The tiny differences slowly begin accumulating. Earth's climate is an extraordinarily complex system. It does not react instantly. The oceans store enormous amounts of heat. The atmosphere constantly redistributes energy around the globe. Clouds reflect sunlight back into space, while also trapping warmth beneath them. Every process influences another. Nothing changes in isolation. Yet every one of those systems depends upon a single source of energy, the sun. Imagine gently lowering the flame beneath a pot of water. The water does not become cold immediately. It changes gradually, almost imperceptibly at first. Only after time passes does the difference become obvious. Earth behaves in much the same way. The first noticeable effects appear not in dramatic disasters, but in subtle patterns. Meteorologists begin noticing unusual temperature trends. Seasonal expectations become slightly less reliable. Some regions experience mornings that feel unexpectedly cooler. Elsewhere, weather systems linger longer than predicted. Climate scientists hesitate before drawing conclusions. Weather is naturally variable. No single unusual week proves anything. But as observations continue, the pattern becomes increasingly difficult to ignore. Small changes in incoming solar energy influence countless interconnected processes. Plants are among the first living organisms to respond. Every leaf quietly depends upon sunlight. Photosynthesis transforms light into chemical energy. It is one of the most important processes on Earth. Without it, food chains collapse. Forests disappear. The oxygen we breathe gradually declines. Fortunately, the changes remain tiny. For now, most plants continue growing normally. But sensitive long-term experiments begin recording subtle reductions in photosynthetic activity. The differences are slight, almost invisible, yet they are measurable. Botanists compare observations from laboratories across different continents. The same quiet signal appears again and again. Life has begun responding, not because the sun has vanished, but because it has changed. The forests themselves seem unchanged to casual visitors. Leaves still sway in the wind. Birds still build nests. Insects still pollinate flowers. Nature continues its patient rhythm. Yet beneath that familiar appearance, millions of tiny biological adjustments are already unfolding. The oceans respond more slowly. Water possesses an extraordinary ability to absorb and store heat. This enormous thermal reservoir protects Earth's climate from changing too quickly. It is one of the reasons coastal regions often experience milder temperatures than inland areas. The oceans smooth out sudden fluctuations. They act as Earth's great stabilizers. But even they cannot remain completely unaffected. Marine scientists begin noticing subtle shifts in sea surface temperatures. Ocean currents continue flowing, yet their energy balance slowly changes. Tiny differences ripple outward through ecosystems that evolve beneath an extraordinarily stable sun. Microscopic phytoplankton drifting near the surface receives slightly less energy. These tiny organisms are almost invisible, yet together they produce a significant portion of Earth's oxygen. Entire marine food webs begin with them. When sunlight changes, everything connected to them changes as well. Fish migration patterns become slightly less predictable, not because disaster has arrived, but because countless delicate relationships inside nature are adjusting simultaneously. Animals respond in surprisingly varied ways. Many species use daylight itself as a biological calendar. Birds migrate according to changing seasons. Insects emerge when daylight reaches particular durations. Flowers bloom in response to carefully balanced environmental signals. Although day length remains unchanged, the quality of sunlight has begun shifting ever so slightly. Biologists observe unexpected behaviors. Migration schedules drift. Some flowering seasons arrive later than expected. Certain insects emerge under conditions that no longer perfectly match the availability of food. No single observation seems alarming. Together, they reveal something profound. Every living organism on Earth has evolved beneath the dependable rhythm of one remarkably stable star. That stability has quietly shaped life for billions of years. Now that rhythm is changing, and life is listening. Even Earth's atmosphere begins behaving differently. The atmosphere is far more than empty air. It is a dynamic ocean of gases, constantly interacting with sunlight. Solar energy drives winds, creates temperature differences, builds clouds, powers storms, maintains the circulation that distributes heat across the globe. When incoming energy changes, even slightly, the atmosphere slowly finds a new balance. Meteorologists begin updating forecasting models more frequently than ever before. Some predictions that once proved highly reliable now show unusual errors. The atmosphere is not becoming chaotic. It is becoming unfamiliar. Scientists realize they are observing something no human civilization has ever witnessed. Not simply weather, not ordinary climate variability, but the first measurable response of an inhabited planet to a changing star. Public attention shifts dramatically. People who had rarely thought about astronomy now follow daily updates from solar observatories. News broadcasts begin every morning with the latest measurements. Children ask teachers whether the sun is still healthy. Families quietly watch each sunrise with renewed appreciation. Photographers capture dawns that look exactly as they always have. Yet, somehow, they feel different. Not because the sunlight has dramatically changed, but because humanity now understands how fragile that light truly is. For generations, the sun served merely as the background of everyday life, a familiar object rarely noticed unless hidden behind clouds. Now, it has become the central character in humanity's story. Every conversation eventually returns to the same subject. Every scientific discovery seems connected to it. Every future plan depends upon understanding it. The sun has not become brighter, nor dramatically dimmer. It has simply reminded us of something we had quietly forgotten. Everything we know, every forest, every ocean, every city, every living creature exists because one ordinary-looking star has spent billions of years doing one extraordinary thing, remaining stable. And now, for the first time in human history, that stability can no longer be taken for granted. As researchers continue studying the growing mystery inside the sun, another realization slowly emerges. Understanding what is happening may take years. Humanity cannot simply wait for answers. If our star is truly changing, then, sooner or later, we must begin asking an even more difficult question. How would our civilization adapt if the unimaginable became reality? For thousands of years, humanity has survived by doing one remarkable thing. Whenever nature presented a challenge, we tried to understand it. When rivers flooded unexpectedly, we learned to predict the seasons. When diseases spread through cities, we searched for their causes. When lightning struck the ground, we eventually discovered electricity. Again and again, our first instinct was not simply to endure. It was to ask questions, to observe, to measure, to learn. Now humanity faces the greatest scientific mystery in its history. The object that made every civilization possible is changing in ways no theory can explain. Panic would solve nothing. Only knowledge could. Within days, observatories across Earth began working together more closely than ever before. Political differences suddenly feel much smaller than the challenge ahead. Data flows continuously between research centers. Every major space agency shares observations. Solar physicists, astronomers, climate scientists, engineers, mathematicians, and computer scientists find themselves working toward a single goal: understand the sun before it is too late. The world's solar telescopes rarely rest. Across deserts, mountaintops, islands, and orbiting satellites, countless instruments remain fixed on our star. Some study visible light, others observe ultraviolet radiation. Some monitor magnetic fields, others measure tiny vibrations moving through the sun's interior. Every wavelength reveals another clue. Every observation becomes another small piece of an enormous puzzle. The sun has always been studied. Now it is watched with unprecedented intensity. Artificial intelligence begins assisting researchers in ways never before imagined. Modern observatories produce extraordinary amounts of information, far more than any human team could analyze alone. Machine learning systems compare decades of historical observations against the newest measurements. They search for hidden patterns, tiny correlations, unexpected relationships buried inside oceans of data. Perhaps somewhere, a detail overlooked by human eyes explains everything. Perhaps not. Even the most advanced computers cannot invent answers that nature refuses to provide. Still, they become invaluable companions in humanity's search. Around the world, new telescopes are proposed. Some would orbit even closer to the sun. Others would travel farther away, observing our star from perspectives never before attempted. Engineers begin designing spacecraft capable of surviving environments once considered impossible. Heat shields become more sophisticated. Sensors become more sensitive. Every improvement offers another opportunity to understand the changes unfolding inside our star. Never before has one scientific question united so much of humanity. Yet even as scientists search for answers, others begin asking different questions. What if understanding comes too late? What if adaptation becomes just as important as explanation? Throughout history, civilizations have adapted to changing environments. People migrated when climates shifted. Communities rebuilt after volcanic eruptions. Nations recovered from devastating earthquakes and storms. But every previous challenge occurred on one small part of Earth. This time, the source lies 93 million miles away. There is nowhere on Earth where the sun does not shine. No nation escapes its influence. No ocean remains untouched. The entire planet shares the same sky. Architects and engineers begin imagining new forms of protection. Massive enclosed habitats capable of carefully controlling light, temperature, and atmosphere. Entire cities covered beneath transparent domes. Underground communities insulated from changing surface conditions. Not because people wish to abandon the outdoors, but because resilience often begins with preparation. Human beings have always built shelters against hostile environments. From desert heat, polar cold, powerful storms, perhaps one day, against an unpredictable star. The idea sounds extraordinary, yet much of modern civilization already depends upon controlled environments. Hospitals, research laboratories, spacecraft, submarines, Every one of them demonstrates humanity's ability to create stable conditions even when nature becomes challenging. Scaling that ability to entire cities would be an immense undertaking, but not an impossible one. The conversation naturally expands beyond Earth itself. For generations, Mars has occupied a special place in human imagination. Its deserts resemble landscapes found on our own planet. It possesses seasons, polar ice, ancient river valleys. Many have dreamed of making it humanity's second home. Now that dream acquires new urgency. Could Mars become a refuge? At first, the idea seems appealing. If Earth grows increasingly difficult to inhabit, perhaps another planet offers hope. But astronomy gently reminds us that Mars circles the very same Sun. Any change affecting Earth would affect Mars as well, not necessarily in identical ways, but the source remains the same. Moving from one room to another inside the same house does not protect you if the foundation itself is changing. Mars has always been a challenging destination. Its atmosphere is incredibly thin. Surface temperatures remain extremely cold. Liquid water cannot persist easily. Radiation constantly reaches the surface. Dust storms can engulf the entire planet, even before our imagined solar crisis. Surviving there required extraordinary engineering. The dream of Mars was never simple. Now it appears even more complicated. Attention gradually shifts toward another possibility: space habitats. Rather than settling on planetary surfaces, perhaps future generations could live inside enormous, rotating structures built in orbit. This idea has fascinated engineers for decades. Long cylindrical habitats slowly rotating to create artificial gravity. Entire ecosystems enclosed within carefully controlled environments. Forests, rivers, homes, schools, observatories, tiny worlds constructed by human hands. Unlike planets, such habitats could be positioned wherever conditions proved most favorable. They could move, adapt, expand. Their environments could be adjusted with remarkable precision. The concept remains challenging, yet it reflects something deeply human. When nature changes, we build, we adapt, we imagine. Some proposals become even more ambitious. Large settlements orbiting Jupiter's moons, communities established around Saturn, scientific stations far beyond the asteroid belt where solar energy changes differently. Each possibility carries enormous technical obstacles. Each requires decades, perhaps centuries, of preparation. But for the first time, humanity begins discussing them not as distant dreams, but as practical necessities. Space exploration quietly transforms into something else: civilization planning. Even if no one leaves Earth immediately, preparations begin. Knowledge becomes one of humanity's greatest priorities. How do we preserve everything we have learned? Libraries already contain millions of books. Digital archives hold unimaginable quantities of information. Yet, every storage system has limits. Engineers begin designing repositories capable of surviving for centuries, perhaps underground, perhaps beneath the moon's surface, perhaps aboard spacecraft placed into stable solar orbits. The goal is simple: ensure that humanity's accumulated knowledge can never disappear entirely. History has taught us painful lessons. Great libraries have burned. Languages have vanished. Entire civilizations have left only fragments behind. This time, humanity hopes to remember everything. Scientists preserve research. Artists preserve music. Writers preserve stories. Engineers preserve designs. Teachers preserve understanding, not only for themselves, but for generations that may someday need them. Another realization quietly emerges. Technology alone cannot preserve civilization. People must preserve one another. Families continue raising children. Schools remain open. Musicians continue composing. Doctors continue healing. Farmers continue planting. Life refuses to pause, simply because uncertainty has appeared. There is something deeply moving about this resilience. Humanity does not stop living while searching for answers. Birthdays are still celebrated. Friends still gather for dinner. Couples still fall in love. Children still laugh beneath the same changing sun. Perhaps hope has never meant believing that nothing bad can happen. Perhaps hope means choosing to continue building tomorrow, even when tomorrow feels uncertain. As months pass, humanity gradually understands something unexpected. Preparing for an uncertain future is not only about survival. It is also about identity. Who are we? If the star that shaped our entire history begins changing, what values deserve preservation? What knowledge matters most? What stories should accompany us wherever the future leads? These questions become as important as engineering itself, because civilizations survive not only through technology, but through memory, through culture, through shared purpose. And while humanity struggles to imagine its own future, the solar system continues its silent dance around the sun. The planets remain in their familiar orbits, each one connected to the same aging star, each one destined to share whatever future awaits it. To understand that future, we must look far beyond our imagined tomorrow, toward the true life cycle of stars themselves. Our story began with an impossible question. What if the sun began to die tomorrow? By now, we have imagined how humanity might react, how scientists would search for answers, how civilization would adapt, how hope might survive, even in the face of uncertainty. But before we continue, it is worth returning to reality, because the true story of the sun is no less extraordinary than our imagination. In fact, it is even more beautiful. The sun will not begin dying tomorrow. According to everything modern astronomy has discovered, our star remains comfortably in the middle of its life. It is approximately 4.6 billion years old, and it is expected to continue shining for roughly another 5 billion years. That number is almost beyond comprehension. 5 billion years. If all of recorded human history were compressed into a single day, the sun's remaining lifetime would still stretch for thousands of years beyond it. Human civilization is astonishingly young compared to the stars. Our species has existed for only a tiny fraction of the sun's life. Everything we have ever accomplished, every city, every civilization, every scientific discovery, every piece of music, every work of art, has unfolded beneath a star that was already unimaginably old before humanity appeared. Yet, like every star, the sun has never been immortal. It was born, it matured, and one day it will grow old. Not suddenly, not violently, but with extraordinary patience. Stars do not age as living creatures do. They change because they slowly consume the fuel that allows them to shine. For billions of years, hydrogen inside the sun's core has been transformed into helium through nuclear fusion. That process has powered every sunrise Earth has ever known. But hydrogen is finite. Very slowly, the balance inside the core changes. Helium gradually accumulates. The region where fusion occurs becomes smaller. The core grows denser, hotter. Gravity slowly gains strength. Eventually, several billion years from now, the hydrogen at the very center of the sun will become exhausted. Fusion in the core will begin to fade. For a brief moment, gravity will gain the upper hand. The core will contract. But rather than extinguishing the sun, this contraction will ignite a new chapter. As the core shrinks, temperatures around it rise dramatically. Hydrogen surrounding the core begins fusing instead. The outer layers of the sun respond by expanding. Slowly, relentlessly, our familiar yellow star begins transforming into something much larger, a red giant. The name can be misleading. A red giant is not cold, nor is it weak. Although its surface becomes cooler than it is today, its enormous size makes it vastly brighter overall. The sun will expand until it occupies an astonishing portion of the inner solar system. From Earth's perspective, if anyone remained here, the sky would become almost unrecognizable. The sun would appear enormous. Its glowing disk would dominate the heavens. Its warmth would steadily intensify. Long before the expanding surface reached Earth's orbit, our planet would already be changing beyond recognition. The first victim would be the oceans. As solar energy increased over millions of years, evaporation would accelerate. More water vapor would enter the atmosphere. Water vapor itself is a powerful greenhouse gas. The warming would intensify further. A slow feedback loop would begin. The seas that have covered Earth for billions of years would gradually disappear. Not overnight, not within centuries, but over immense stretches of time. Rivers would dry. Clouds would become increasingly scarce. The blue planet would slowly lose its most defining feature. Without liquid oceans, Earth's climate would transform completely. Forests would vanish. Complex ecosystems would collapse. The atmosphere itself would change. Life, as we know it, would no longer be possible. Whether humanity still existed by then is another question entirely. If our descendants remained within the solar system, they would almost certainly have left Earth long before this stage. Our home would become a silent world, a monument to billions of years of life, a place where every mountain, every valley, every fossil quietly testified that a thriving biosphere once flourished beneath an ordinary yellow star. Mercury would almost certainly disappear first. Its tiny orbit lies deep within the future red giant's expanding atmosphere. The smallest planet would simply be consumed. Venus would likely follow. Its already inhospitable surface would vanish beneath the sun's swollen outer layers. Earth's fate is slightly less certain. Some computer simulations suggest that our planet may also be engulfed. Others indicate that as the sun loses mass during its later stages, Earth's orbit could slowly drift outward. The reduced gravity would allow the planets to move slightly farther away. Whether that outward movement would be enough to save Earth remains an open scientific question. But even if our planet escaped physical destruction, it would already be lifeless. Its oceans gone, its atmosphere transformed, its surface scorched beyond recognition. Survival would no longer depend on Earth's existence. It would depend on where humanity had chosen to go long before. Farther from the sun, another story unfolds. Mars, so often imagined as humanity's second home, would become warmer. Ice locked beneath its surface could melt. Temperatures might briefly allow liquid water to exist in some places. For a time, the red planet could become surprisingly Earth-like. Not permanently, but during part of the sun's transformation, Jupiter's icy moons would change as well. Europa, Ganymede, Callisto, worlds that today hide frozen oceans beneath thick shells of ice, might experience conditions unlike anything they know now. Farther still, Saturn's moon Titan, with its thick atmosphere and lakes of liquid methane, would receive much more sunlight than today. The habitable zone, the region where temperatures allow liquid water, would slowly migrate outward through the solar system. It is a remarkable thought. As Earth grows increasingly hostile, other worlds may briefly become more welcoming. Not because they changed, but because the sun did. Eventually, the red giant phase itself comes to an end. The sun becomes unstable. Its outer layers begin drifting away into space, not in a single explosion, but through powerful stellar winds lasting thousands of years. Layer after layer gently escapes. The expanding shells of glowing gas spread outward across the solar system, illuminated by the hot core left behind. They create one of the universe's most beautiful sights, a planetary nebula. Despite its name, a planetary nebula has nothing to do with planets. Early astronomers simply thought these glowing clouds resembled distant planets when viewed through small telescopes. In reality, they are the farewell of dying stars. Immense bubbles of colorful gas slowly expanding into the galaxy. Within those clouds travel elements forged during the star's lifetime. Carbon, nitrogen, oxygen, the raw materials from which future stars, planets, and perhaps even future civilizations will someday emerge. Stars rarely keep their creations. Instead, they return them to the universe. The sun will do the same. At the center of the fading nebula, one object remains: the core, no longer capable of sustaining fusion, no longer producing new energy. Only the leftover heat from billions of years of nuclear reactions remains. This object is called a white dwarf, roughly the size of Earth, containing nearly half the sun's original mass. so dense that a single teaspoon of its material would weigh many tons. It no longer shines because of fusion. It simply glows, slowly radiating away the heat accumulated across billions of years. For unimaginable stretches of time, the white dwarf gradually cools, growing dimmer, redder, colder. Eventually, after trillions of years, it becomes something the universe has not yet had enough time to create. A black dwarf, a cold, stellar ember. The silent, final stage of a star like our sun. None exists today. The universe itself is still too young. That realization is strangely comforting. Our cosmos has not yet reached old age. It is still in the early chapters of its own story. The sun's future reminds us of something profound. Nothing in the universe lasts forever. Not mountains, not oceans, not stars. Everything changes. But change in the cosmos is rarely rushed. It unfolds with astonishing patience, measured not in days or years, but in millions and billions of years. Compared with those timescales, our imagined crisis at the beginning of this story becomes exactly what it was intended to be. A thought experiment, one that allows us to appreciate something we often overlook. The greatest miracle of the sun is not that it will one day die. Every star does. The true miracle is that for billions of years, it has remained so wonderfully stable. Stable enough for oceans to form, for life to evolve, for intelligence to emerge, for one curious species to begin asking questions about the universe. Perhaps that remarkable stability has always been the sun's greatest gift, and perhaps only by imagining its loss do we finally understand its value. Imagine that the day has finally come. Not tomorrow, not next year, not even in the lifetime of anyone alive today, but in a future so distant that human history has become almost impossible to remember. The sun hangs low above the horizon. Its light is different now, softer, redder, older. The sky glows with colors no human civilization has ever witnessed. Every sunrise, every sunset, carries the quiet beauty of a star approaching the final chapters of its life. Someone stands beneath that sky, perhaps a human, perhaps a distant descendant whose appearance has changed with millions of years of evolution. Perhaps an artificial intelligence preserving the memory of its creators. Or perhaps another form of life entirely. Whoever they are, they understand something that every generation before them only imagined. This is one of the last sunsets our sun will ever give. How strange that such an immense event arrives so quietly. There is no dramatic countdown, no sudden darkness, no cosmic explosion visible across the heavens. Stars rarely end with violence. Most simply change, patiently, almost gently. The observer watches the horizon. The sunlight stretches across an ancient landscape. Perhaps Earth is already gone. Perhaps this farewell takes place from Mars, from a space habitat drifting through the outer solar system, or from a distant colony orbiting another star. The location matters less than the memory, because wherever humanity exists, the sun will always be remembered as home. Every civilization carries an origin story. Ours begins with a yellow star. Every language ever spoken, every poem ever written, every scientific breakthrough, every first step, every goodbye, all unfolded beneath its light. It is difficult to separate human history from the sun itself. The pyramids reflected its morning rays. Ancient ships crossed oceans, guided by its position. Farmers planted crops according to its seasons. Children learned to tell time by its movement across the sky. Artists painted it. Writers described it. Musicians celebrated it. Scientists devoted entire careers to understanding it. The sun became so familiar that people rarely noticed how extraordinary it truly was. Perhaps that is the nature of life's greatest gifts. The things we depend upon most often become invisible through familiarity. Breathing, gravity, the warmth of another person's hand, the quiet rhythm of sunrise. Only when we imagine losing them do we fully recognize their importance. Different cultures might choose different ways to say goodbye. Some might gather in silence. Others might sing ancient songs preserved across thousands of generations. Some could recite stories passed down from ancestors who once lived on Earth beneath blue skies and white clouds. Others might simply watch. No words, no ceremonies, only quiet gratitude. For billions of years, the sun asked for nothing. It simply continued shining, patiently providing energy for every forest, every ocean, every ecosystem that ever existed on Earth. It never celebrated its own generosity. It simply existed. Perhaps that is why imagining its farewell feels surprisingly emotional. Not because stars possess feelings, but because we do. Our memories are inseparable from its light. Every family photograph taken outdoors, every childhood afternoon spent beneath clear skies, every walk through autumn leaves, every sunrise watched from a quiet beach, every golden evening shared with friends, the sun illuminated them all. Even moments that seemed ordinary become extraordinary when viewed from the future. Imagine remembering Earth's blue oceans after they have long disappeared. Imagine remembering forests that no longer exist. Imagine remembering birds greeting the morning, rain falling gently across fields, snow reflecting winter sunlight, clouds drifting lazily across summer afternoons. Perhaps memory itself becomes the final refuge of a vanished world. Human beings have always preserved memories, at first through stories, then through writing, later through paintings, photography, film, digital archives. Perhaps future generations preserve entire simulations of ancient Earth, perfect recreations of forests, cities, mountains, the sound of waves reaching a shoreline, the laughter of children playing beneath ordinary sunshine, not because they can return, but because remembering matters. Memory is one of civilization's quiet forms of survival. Even if places disappear, the stories remain. The observer lifts their eyes toward the aging sun once more. How many mornings has this star witnessed? How many billions? How many countless living creatures opened their eyes beneath its light? Dinosaurs, ancient mammals, the first humans, every civilization, every explorer, every dreamer. The sun outlived them all. Yet, even stars cannot escape time. Perhaps that is the lesson hidden inside every sunset. Nothing lasts forever, not because the universe is cruel, but because change is woven into reality itself. Without change, stars would never be born, planets would never form, life would never evolve. The atoms inside your body were created because older stars reached the ends of their own lives long before the sun existed. Endings make beginnings possible. The sun itself is living proof of that cycle. One day, its own atoms will help create new stars, new planets, perhaps new oceans, perhaps new forms of life. Somewhere in the distant future, another curious civilization may stand beneath another yellow star, completely unaware that tiny fragments of our sun now shine within theirs. The universe wastes remarkably little. It transforms again and again. The observer realizes that saying goodbye to the sun is not only saying goodbye to a star, it is saying goodbye to the entire stage upon which human history unfolded. Without the sun, there would have been no Earth as we know it, no atmosphere, no forests, no oceans, no people. Every chapter of our story was written beneath its patient light. Perhaps every civilization eventually discovers that home is not simply a place. It is a source of light, a beginning, a sky remembered long after it disappears. The sun slowly sinks beyond the horizon. One final sunset, not because darkness has won, but because another chapter of the universe quietly begins. The observer remains still for a long time, watching the fading light, not with fear, not even with sadness, but with gratitude, because for billions of years, one ordinary-looking star accomplished something extraordinary. It gave a small planet enough time for life to awaken, enough time for intelligence to emerge, enough time for one curious species to ask where it came from and where it might someday go. Perhaps no star could ever offer a greater gift, and as the last light slowly fades, one final question remains. If the sun has always been so much more than a star, what has it truly represented throughout all of human history? Our journey began with an ordinary morning, a sunrise so familiar that it barely seemed worthy of attention. At first, we imagined something impossible. What if the sun began to die tomorrow? We followed that thought through science, through imagination, through uncertainty, through the resilience of humanity. We watched our civilization search for answers. We imagined adapting to a changing star. We looked billions of years into the future to witness the true destiny of the solar system. And now, we return to the present, to this moment, to the quiet light that may already be entering your room. Perhaps the greatest surprise of this journey is not what we learned about the sun. It is what we learned about ourselves. The sun has never been just another star. Astronomically speaking, it is remarkably ordinary, a medium-sized yellow dwarf, one among hundreds of billions of stars in the Milky Way. Nothing about it appears especially unusual when viewed from across the galaxy. And yet, for us, It is the most extraordinary object in the universe. Not because it is the biggest, or the brightest, or the rarest, but because every moment of our existence has unfolded beneath its light. Every human being who has ever lived shared one common experience. They all lived under the same sun. The names changed. The languages changed. Empires rose and fell. Religions appeared. Nations formed. Borders shifted. Technology transformed the world beyond recognition. Yet, through every generation, the same star continued rising every morning, patiently, faithfully, without asking for recognition, without demanding gratitude. It simply continued shining. There is something deeply humbling about that thought. Human history often feels enormous to us. Thousands of years, countless civilizations, millions upon millions of lives. Yet from the sun's perspective, all of it happened in an instant. Our entire recorded history occupies only the smallest fraction of its lifetime. If the sun could somehow remember, human civilization would feel like a single heartbeat. And still, within that heartbeat, an extraordinary story unfolded. Life appeared. Consciousness emerged. Curiosity awakened. A species began asking questions that no other known creature had ever asked. Where did we come from? Why do the stars shine? How old is the universe? What happens when stars die? Those questions eventually led us back to the very object that inspired them, the sun. There is a beautiful symmetry in that. The star that made our existence possible also inspired us to understand existence itself. Perhaps that is why astronomy feels different from many other sciences. When we study distant galaxies, we are also learning about ourselves. When we study stars, we discover our own origins. Every atom of carbon inside your body, every atom of oxygen you breathe, every atom of calcium inside your bones was forged inside stars, not our sun, but stars that lived and died billions of years before it was born. Their final moments enriched the galaxy with heavier elements. Those elements became part of new clouds of gas, new stars, new planets, eventually Earth, eventually you. We often speak about being children of the universe. That is not merely poetry. It is chemistry. The universe literally became conscious through matter that once existed inside ancient stars. Perhaps that is one of the most astonishing ideas modern science has ever revealed. The cosmos has spent nearly 14 billion years evolving, and somehow part of it learned to wonder about itself. When you look at the sun, the universe is, in a sense, observing one chapter of its own story. Not through magic, not through intention, but through consciousness, through minds capable of asking questions. That may be one of humanity's rarest gifts. Not intelligence alone, but awareness. The ability to pause during an ordinary sunrise and realize how extraordinary it truly is. Imagine explaining our civilization to someone who had never seen Earth. You might describe our cities, our music, our science, our art, our languages, our dreams. Yet behind every one of those achievements stands the same quiet companion, the sun. Without its remarkable stability, none of them would exist. Its greatest gift was never simply warmth. It was time. Time for oceans to form. Time for continents to change. Time for evolution to experiment. Time for forests to grow. Time for mammals to appear. Time for humanity to emerge. Billions of years of uninterrupted opportunity. Perhaps that is the rarest resource in the universe. Not energy, not matter, but time. The sun gave Earth more than enough of it. Enough for life to become unimaginably diverse. Enough for one species to become curious enough to build telescopes. Enough to ask impossible questions, including the one that began tonight's journey. What if the sun began to die tomorrow? And now we know the answer. According to everything modern astrophysics has taught us, it will not. The sun remains healthy, stable, patient. It will continue shining for roughly another 5 billion years before entering the final stages of its life. That fact is wonderfully reassuring. Our imagined crisis belongs only to imagination. Reality is far kinder. The sun has no intention of leaving us tomorrow morning. In fact, long after every person alive today has become part of history, long after today's cities have changed beyond recognition, long after new generations have written stories we cannot imagine, the sun will still rise. It will continue illuminating mountains, oceans, forests, clouds, and perhaps future civilizations that have not yet been born. That realization quietly transforms every ordinary morning. The next time you wake before sunrise, perhaps you will notice something different, not in the sun itself, but in the way you see it. The light entering your window has traveled across space for about 8 minutes. Before touching your face, it crossed 150 million kilometers of empty space. Before beginning that journey, it spent thousands of years slowly making its way outward from the sun's core. And before that, its energy was created by nuclear fusion deep inside a star that has patiently supported life for billions of years. Every sunrise carries an extraordinary history, one we almost never notice. Perhaps that is the quiet lesson hidden inside astronomy. The universe is filled with astonishing things, not only black holes, or distant galaxies, or exploding stars. Sometimes, the greatest wonder is the one that greets us every single morning. So tomorrow, when the sun rises once again, as it almost certainly will, perhaps pause for just a moment. Feel its warmth. Notice its light. Remember that every civilization before us depended upon that same gentle star. Remember that every breath you take is possible because of it. Remember that your entire existence has unfolded beneath one remarkably patient sun. And perhaps allow yourself one final thought before sleep. The greatest gift the sun has ever given humanity was never simply its light. It was the billions of quiet years that light continued shining, long enough for the universe to become aware of itself, long enough for us to exist, long enough for someone, somewhere, on a small blue planet, to look up at an ordinary sunrise and wonder, Good night.